Hello, everybody. Today we're going to do a lesson on solving systems of equations that could involve a combination of lines and quadratic equations. So it can be lines and parabolas and circles and so on, and see where they intersect. And so for each problem, we're going to solve the system algebraically, and then we're going to graph it and see what the equations look like, and confirm that the solution that we got algebraically matches with what we see on the graph. And so for the first one, we have a line and a parabola. I can tell this is a parabola because only one variable is squared, whereas if it was a circle, it would have two variables squared. And so in this case, for most of these systems, we want to solve for one of the variables. And so in this one, I'm going to solve for y. So I'm going to write y equals 3x minus 7. And then I'm going to substitute that in place of y in the other equation. So that's true for most of these systems of linear and quadratic equations. We want to, if we have one line, we want to substitute in for either x or y in the other equation. So here I have 3x minus 7 in place of that y, plus 4 equals 2 times, if I expand this, is x squared plus 10x plus 25. And so now I have 3x minus 3 equals 2x squared plus 20x plus 50. And so I have 0 equals 2x squared plus 17x plus 53. Okay, and this is a quadratic equation. We can try factoring. Because of the 2 in front and the numbers that we have here, the 17 and the 53, that looks like that would be pretty tough to factor. So the next step, if we can't factor this, is to use the quadratic formula. And so we get x equals negative 17 plus and minus the square root of b squared. So 17 squared is 289 minus 4 times a times c over 2a, which would be 4. And so 289 minus 4 times 2 times 53 is negative 135 over 4. And so that means we have no real solutions because of the negative under the radical. So if we get no real solutions, that tells us that these graphs don't intersect. And so what we want to do is graph this in Desmos and confirm that that's actually the case. Go ahead and take out a Chromebook or a computer and open up Desmos and type in both of those equations. Okay, so I have both of these equations graphed in Desmos, and we see that the first one is a line and the second one is a parabola, and they do not intersect anywhere, and that's why we get no solution. Because when we solve a system of equations, what we're doing is we're finding the intersection of the graphs, and these graphs do not intersect, and so that makes sense why we got no solution for our answer. Okay, so that one is confirmed. Go ahead and try example B. So pause your video, try example B, and don't forget to graph it in Desmos to confirm your solutions at the end. Okay, so for example B, we again have a parabola and a line, and we could try to solve for x or y in this equation and then substitute into the other one, but it might actually be easier in this case since we have an expression for for y already here. We can substitute the other way. So that would be 3x minus 2 times 1/4 x minus 3 squared equals 13. And so I just put this expression in place of that y. And so now I have 3x minus 2 times, let's see this where it is here. And so that's 1/4 times, or we can do the 2 times the 1/4, and then that would be 1/2. And then x minus 3 squared is x squared minus 6x plus 9 equals 13. And so now we have 3x minus 1/2 x squared plus 3x minus 9/2 equals 13. And so that is negative 1/2 x squared plus 6x. And then if we move the 13 to the other side, that's going to be minus 35/2 equals 0. And then if we multiply both sides by 2 to get rid of the fractions, or by negative 2, then we have a quadratic x squared minus 12x plus 35 equals 0. And that is factorable. X, let's see, minus 7 and x minus 5 gives us negative 12x in the middle and 35 at the end. And so that gives us two solutions, x equals 7 and x equals 5. And so we're going to have x equals 7 and x equals 5. And so to find the y values, we can plug them into the line, or we could plug them into the parabola. So that might be easier actually. So then we have y equals 1/4 of 7 minus 3 squared. And so that is y equals 1/4 of 4 squared, which is 16, and we get 4. So our y value is 4. If we plug in the other y value of 5, the other x value of 5, then we get 1/4 of 5 minus 3 squared, and that is y equals 1/4 of 4, which is 1. And so our two intersection points are 7, 4, and 5, 1. And then to confirm graphically, I have this graphed in Desmos here. Here are the two curves. So again, we have a parabola and a line, and our solutions that we got were 7, 4, and 5, 1. So if I plot the point 7, 4, that is right up here, and that is definitely in one of the intersections. And then the other point is 5, 1. And that looks like another intersection right here. And so those 2 points are confirmed on our graph. Okay, for the next example, this time we have, looks like 2 circles. I can tell that they're both circles because x and y are squared, and the coefficients of both are 1. So there's a 1x squared and a 1y squared, which makes those both circles. And so what we can do here, I'm looking at, we could possibly do some kind of substitution if we solved for, well, it would be hard to get any of the variables alone, but if we do the elimination method, I notice that all of this stuff will go away if I subtract these two equations, and then I'll be left with this part, which only involves y's. So that's what we'll go ahead and do. So substitution or elimination are methods that you learned in algebra. They will sometimes work for these quadratic systems as well. So I'm going to subtract this equation from the one up above it. And so that gives me 0, 0, 0, and then negative 2y minus negative 8y, that gives me positive 6y. And negative 20 minus 4 is minus 24 equals 0. So then I get 6y equals 24, y equals 4. And then if I plug that in to either equation in place of y, I'll plug it into the first one. I get x squared plus 16. So if I'm plugging in 4 for y, that becomes 16 minus 4x minus 2y becomes minus 8, and minus 20 equals 0. So now that simplifies to x squared minus 4x minus 12 equals 0. And if we factor that, x negative 6 plus 2 gives me negative 4x in the middle and negative 12 at the end. And so we only got one y value, that's 4, but we got two x values, x equals 6 and x equals negative 2 to go with that. So we're going to have 6, 4 and negative 2, 4. So two different x values, but only one y value. And so that gives us two intersection points. And so again, we'll graph that in Desmos and confirm those two solutions. So we have both circles graphed in Desmos, and we do see there are two intersection points, and this one is at 6, 4, and this one is at negative 2, 4, confirming the two solutions that we got here. So next I'd like you to try example D. So go ahead and pause your video, try example D, and don't forget to graph your solutions in Desmos, and then press play when you're ready to confirm your solution. So for this one, we may be able to use the elimination method as well. Let's see. If we multiply the top equation by negative 2, we would have 2y squared minus 2x plus 22y plus 52 equals 0. So then if we add those equations, the y's will go away, and we'll have negative x plus 8 equals 0. So then x equals negative 8. Or actually we would get negative x equals negative 8, which means x equals positive 8. And then if we substitute that into either equation, I'll plug it into the top one, we get negative y squared plus 8 minus 11y minus 26 equals 0. So then that is negative y squared minus 11y minus 18 equals 0. And multiply everything by negative 1 is y squared plus 11y plus 18 equals 0. And so now we can try factoring that. And 11 is 9 and 2, so y plus 2, y plus 9. And so that gives us y equals negative 2 and y equals negative 9. And so we have one x value, 8, that goes with two different y values. And so those are our two solutions. And then when we graph those in Desmos, we see both graphs, two parabolas, and they intersect at 8, negative 2 and 8, negative 9, confirming the two solutions that we got algebraically. So that's it for today's lesson. Have a great day.